See guys, we have solved up to the second iteration. After that, I have made this table. Okay, this table. How to make this table? Again, you have to solve the iteration up to the 7. Then you will get the root of the equation for the given equation cos x minus 1.3 into x. This value you will given the value for the x3 0.6210. This will be satisfy the given condition. Which condition? Root of x2 minus x1 is less than accuracy. This condition will be satisfied. Okay, we want to satisfy that condition. In the first iteration, what we have done? We have assumed the initial guesses. What is the value of x1? We have assumed that x1 is equal to 0, and you will get the y1 means f of x1. When you put the value in the given equation x1, then you will get the cos 0 is equal to 1, right? And minus 1.3 into 0 means 0. You will get the y1 value. After that, we have assumed the second initial guess x2 is equal to 1. Then you can easily find out the value with the help of given equation. Y2 is equal to minus 0.76. We have seen. Okay. Then up to that, you know that you have to check the condition f of x1 into f of x2 or y1 into y2 is less than 0 or not. Means this 1 into minus 0.76 is less than or 0 or not? Yes, this condition is satisfied. This equation is less than 0. y1 into y2 or f of x1 into f of x2 is less than 0. That's why we are considered the initial guesses are right, 0 and 1. Then after that, we have find out the first iteration value. Which is the first iteration? Yes, we have applied in the step number 2 bisection method iteration formula. What is the bisection iteration formula? x3 is equal to x1 plus x2 divided by 2. Okay, x1 plus x2 0 plus 1 divided by 2, you will get the 0.5 is there. Okay, and similar way, we know the equation f of x3 is equal to cos x3 minus 1.3 x3. When you put the x3 value in that equation, then this equation you will get the positive, given the positive value 0.2275. You will get the y3, or we can say the f of x3 value. Okay, then we have replace in the step number 4 is there, right? Replace value x1 or x2 by x3. You have to check the sign of each value. Suppose x1 and x2 are having the x1 and x3 having the same sign, then we can write x1 is equal to x3 or f of x1 is equal to f of x3. We'll replace that value with x3, right? Then with the help of that, we have checked the in the last number step number 5, whether the mode of x2 minus x1 is less than accuracy or not. Then when you put this value in that equation, then we will get the accuracy 0.5. But we required accuracy is a 0.01. That's why this condition is not satisfied. Again we are going to the iteration number 2. Iteration number 2. Again, what is our initial guesses? We know that x1 is equal to 0.5 and x2 as it is 1 is there. Okay, 0.5 is the new guess. Okay, and x2 as it is. These two guesses. And with the help of, we are using again same procedure. Find out the value of y1, y2 and x3 and y3. You will get the accuracy is 0.25. Up to that, check that up to the 7 number equation. 7 number equation. We have doing that equations. Okay, only you have to change the value or find out the new cases x1 and x2, and you have to use the same procedure, step number 2 to step number 5. Okay, till we'll get mod of x2 minus x1 is less than accuracy. See in the step number 7 or equation number 7, we have the value of x1 0.6093, and that time we'll get the y1 value is 0.027. Okay, similar way we have found the value of x2 0.625, then y2 is a minus 0.001537, x3 0.617, and y3 0.0131. But if you have checked the accuracy in the iteration number 7, what is the accuracy we have? Check that. How to calculate that again? Mod of x2. Where is the x2? 0.625 minus what is the x1? 0.6093. Then when you minus that value, then you will get this accuracy 0.078. I will write here 0.0078. Okay, this value is less than 0.01. Check that. This value is less than or not? We have the 0.00 and we require the accuracy 0.01, less than that value. Okay, this condition is satisfied. This condition is satisfied. Then we will stop the solution. Then we will stop the solution and find the root of equation. Means we will get the new guesses for that x1 and x2. What is this new guess? 0.6171, and second guess is a x2 is equal to 0.625. Okay, in the iteration number 8, once you have satisfied this condition is iteration number 7, then you have to only find out the root of equation in the iteration number 8. Okay, then how to find out which value is satisfied that condition? Check that. What is the x1? 0.6171 plus 0.625 means x1 plus x2 divided by 2. You will give the value of x3. You will get the value of x3 0.6210. This is the value of x3, or this value is satisfy the root of equation. Okay, the root of equation x3 is equal to 0.6210. This is your final answer. Okay, all of you getting? You have to use the same steps, only you have to satisfy this condition. Suppose in the first iteration this condition will be satisfied, then you have to stop up to the first iteration. If you are getting the third iteration, then you have to stop up to the third equation. You have to satisfy that condition. Sometimes that accuracy is not given. You have to give only the iteration. You have to find out that iteration. Okay. Guys, remember that. What is the first step? First step, you have to remember the 5 steps when you solving the problem by bisection method. Okay, using bisection method. First step is you have to check whether the assuming guesses are right or wrong. Means you have to assume the guesses. Sometimes in the example you have given the guess. Okay, means x1 value and x2 value. You have no need to assume that initial guesses. But if you have not given initial guesses, then you have to assume. Okay, you have to assume and check the sign of that, both x1, f of x1 or f of x2. That sign, if you are getting the opposite sign, then your assumption is right. If you are not getting the opposite sign, then your assumption is wrong. So you have to check whether you are assuming initial guesses are right or wrong. Once you are assuming initial guesses are right, then you have to go to the step number 2. In the step number 2, you have to apply the bisection method iterative formula. What is the bisection method iterative formula? X3 is equal to x1 plus x2 divided by 2. Okay, you will get the new x3 value. Once you have got that x3 value in the step number 2, okay, then you have to go to the step number 3. In the step number 3, you have to check whether the sign of f of x3 either positive or negative. Positive or negative. Okay, you have to check in the step number 3 f of x3 sign is either positive or negative. Then next step, once you have find out the sign of f of x3, then step number 4, you have to replace x1 or x2 by x3. Okay, you have to check the sign. What is the sign of x1? What is the sign of x2? What is the sign of x3? Okay. Then after that you can check also what is the sign of x1, f of x1, f of x2 and f of x3. You have to check this sign. Suppose x1 and x3 having the same sign, then you can replace that x1 by x3. x1 by x3, or you can write x1 is equal to x3 or f of x1 is equal to f of x3. Okay, that thing you have to write here. That's why here you will get the same value. Check that this value y3 is equal to here y1. If you have checked in the second and third iteration, here check that y3 is equal to what? y2, because having the same sign. Again check that y3 is equal to y2. Okay, you have to check that. Okay, then you will get the different value again this will be changed here in the iteration number 5. This one y3 is equal to y1 because having the same sign. Okay, as that of f of x3. Okay, this is the step number 4. Once you have calculated f of x1 sign, f of x2 sign, f of x3 sign, then next step, last step, whether you have to check that mod of x2 minus x1 is less than accuracy or not. Mod of x2 minus x1 is less than accuracy or not. Check that 0.5 is greater than 0.01. Then we have kind of second iteration. Again 0.25 is greater than 0.01. Again third iteration 0.125, 0.01 is greater. 0.125 is greater than 0.01. Up to this sixth iteration 0.0156 is there. Okay, guys, remember that always you have to consider after decimal point at least 3 digits. Okay, this value is greater than this one, then last digit 0.078 is less than 0.01. This condition is satisfied. If this condition is not satisfied, then you have to repeat the step number 2 to 5. Step number 2 to 5 till we get this condition is satisfied. Mod of x2 minus x1 is less than accuracy. Okay, all of you getting? If you have any problem in the bisection method, then again we will solve 2 to 3 numericals on that. But you have to try yourself at the home. Okay, if you are not getting, then again I will take the second numerical in the next lecture. Today we will stop here. Thank you.